Here's 3.6. It may be 3.5. I don't know. I think it's 3.6, and it's called curve sketching. So all these derivatives we've been doing, now we're going to sketch the curves. And let me give you some background stuff on sketching derivatives. So if I have a derivative that goes like that, all right, that derivative has hills and valleys. So it has some hills and has some valleys. So that means relative mins and maxes. All right? It's continuous and differentiable. And it's differentiable. All right? You can have the graph, the derivative would be derivative is greater than 0, looks like this. The graph will rise. And if it's this way, the derivative is less than 0, and that means the graph falls. Okay? Also, if you're looking at curves, if we're looking at the function, and watch this is going to help you out. Here's the function. All right, and this is, we're going to talk about the slope here. So I'm going to make a little table here. Okay, if the function is increasing or decreasing, then the slope is increasing or decreasing. So let's talk about this. If the function is increasing and the slope is increasing, that means it's going that way. Because if you check out all the lines of the derivative, look at all these slopes. They're getting bigger and bigger, or steeper and steeper. Okay, and the function's also increasing. If we're going to talk about the function decreasing and the slope increasing, this is what we're talking about, like that. Because all these slopes are increasing, getting closer to 0, becoming more negative and then getting to 0. The slope is decreasing, but the function's increasing. Now we're concave down. And that, if you look at the slopes of these lines, here, 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 they're all decreasing the slope. And this one would be that way. All the slopes are still decreasing and the function's decreasing. So these guys are the concave downs. These are the concave ups. Just looking at slopes. Okay? All right. So let's do one of these. All right, let's do one of them. Let's do a problem. So what I'm going to tell you, what our goal here is to get a problem, find all the stuff, all the derivative without a calculator, derivative, critical numbers, points of inflection, and use all that and sketch a graph of it. So here we go. As an example, I have f of x equal to x cubed minus 3x squared plus 3. By the way, I'm in the security office, so I'm very secure. The library was way too loud for me today. So now if we take the derivative of this guy, we'll get 3x squared minus 6x. All right, set that equal to 0, so I'll factor out a 3x, and I'll get, help me out, x minus 2 equal to 0, so that means that either x equals 0 here, so that's a critical number, or x equals 2, and we'll try our sign analysis and see what's happening. So here's our sign analysis, 0, 2. Anything less than 0 here, like negative million, negative times negative would be positive. If I plug in 1, I'll get negative. And if I plug in like a million, I'll get positive. So we see we have a relative max at 0, 3. Remember, put it into the original. And we have a relative min at 2, that's 8 minus 12. 8 minus 12 is negative 4 plus 3. I'm guessing negative 1. That's the worst part about this. I forget how to do all the arithmetic. But is that right? I'm just got to double check. It's 8 minus 4 times 3 is 12. That's negative 4 plus 3. I think I'm good. Now we're going to go for the poi. So I'm going to do the second derivative of x. So here's the first derivative. I'm going to take the second derivative. I'm going to get 6x minus 6. And when I set that guy equal to 0, I find that my possible poi is 1. So I'm going to check to the left and to the right of 1. And if I check like negative a million again, this is negative times positive, it's negative. If I test something greater than 1, it's positive. So I have a concave down here, concave up here. Remember, this is increasing, decreasing, increasing. I'm about to start my graph. It's a sketch, okay? So let's get some axes. All right, here's some axes. All right. All right, let's label some points here. I'll do it in red. So some points that are important here are 0, 2, and 1. So here's 0, 1, and 2. And let's see what's happening. For anything from negative infinity to 0, it's increasing. And it's a relative max. I have a relative max here. This is a point of inflection here, and this is a relative min. Oh shoot, it's 2, negative 1. So actually my point of inflection and my relative min is screwed up a little bit. My relative min is 2, negative 1. So here's 2, negative 1. Alright, we'll call that 2, negative 1. And my poi is 1 comma, well, I gotta put it into the original. So it's going to be 1 minus 3 minus plus 3. So it looks like 1 comma 1, actually. So at 1, 1, there's a point of inflection. Boy, 1, 1. I forgot to get the point. All right. So we got to talk about concave up and concave down. So at the point of inflection, all right, 0, anything from 0, this is positive. So everything here is increasing. Then it starts decreasing after 0 and increasing. So I have decreasing here, after 0, increasing, and then after this guy, it's decreasing again. So these right here, I'm just kind of showing you this one, the first derivative. Increasing, decreasing between 0 and 2. Whoa. Oh, I screwed these, at least the arrows up. Jeez. Alright, this guy's increasing here, decreasing here, and increasing there. This gets a max. That's a poi. So, let's see. Let's remember back up above and increasing to a relative max. So I believe, let's see if I'm graphed correctly. That 1, 1 is making me nervous. 1, 1, yeah, 1, 1, 1 is good. 0, 3 is a relative max. Lousy. I'm getting there. It's 1, that's 2, and here's 3. 0, 3, here's our relative max. At 0, 3. It helps if you can graph right. Jesus. Alright, so I'm figuring it's going to do this. Increasing to here, relative max. Decreasing. And then it decreases here. But notice the concavity is changing, and then it's going to increase again. So check it out. We have concavity changes from concave down to concave up right at that green point. We also have increasing up to here. My pen goes up to here, then starts coming down, and then comes back up. So that is the sketch of this graph. F of x equals x to the third minus 3x squared plus 3. So that's how we sketch our graphs. Notice I take it in sections. All right? And if I've done it right, the math police will just pass me by. I guess I've done it right, because if I didn't do it right, the math police would have taken me down. All right? So once again, you look at areas where it's up, where it's increasing, decreasing, and I will use all of the things I talked about here, especially this. The more you do, the better it will be, or the easier it'll get. All right? And just take it step by step. These are ranges of what's going on with your graph. And then here's your points. Make sure you know how to plot points, unlike me, where I plotted the wrong points. So, of course, I bumbled for a little bit. And concave up and concave down. All right? Just because it's going down doesn't mean it's always concave down. This is the point where it changes from concave down to concave up. All right? Hopefully you understand, and we'll practice a few tomorrow.